I'm Anil Kumar, and in this video I'll make sketching polynomials such an easy thing for you. We have g of x equals to x times x minus 2 whole square times x plus 1 whole square. Let's analyze the polynomial. That means let's find out a couple of things about it. First, let's begin with x-intercept. So what are the x-intercepts? These are actually our zeros, right? These are our zeros. When we talk about zeros, we should also talk about multiplicity. These are critical things to consider before sketching. So first zero is for x. These are the three factors you can see, right? First zero is because of this x. That zero is at x equals to 0, right? The second one is because of the second factor, which is x minus 2, which is at x equals to plus 2. And this will be 0 at x equals to minus 1, right? Minus 1. So we'll write, okay, I should have written like this, x equals to minus 1. Okay, so these are the three zeros we get. This is because of first factor, this is because of the second factor, and the third factor 0. So we have three zeros. Let's write down their multiplicity. This is linear multiplicity is 1. Multiplicity is that power on the top, which is 2, and here the multiplicity is 2. Remember, if it is linear, then it is going to cross the graph in a straight line, and if it is 2, it should actually turn with kind of like this, right? Either way it could be. So at present we'll just draw like this. So first part we have done is to find and analyze x-intercepts, in which we should do zeros and multiplicity. Then easy part, which we can read from the equation, and we'll find what is y-intercept. So we'll try y-intercept. When we say y-intercept, we are trying to find the value of the function when x is 0, right? So g 0. So let's substitute 0 here. As soon as we substitute 0, we get 0. X 0 means everything is 0. 0 times anything is 0. So y-intercept is at the origin. Correct. Now the next step which we have to look into before sketching is end behavior, right? So we are now looking into end behavior. Let me write in capitals. Very critical. End behavior is what happens to the function when x approaches negative infinity and when x approaches positive infinity. And that is really decided by what? By leading coefficient. Is it okay? By leading coefficient. And what? And by degree of polynomial. Degree, we have to check whether it is odd degree or it is even degree. That is what we have to check to find the end behavior of our function. So let's look into it. So what we see is, as far as the degree is concerned, 2, 2 and 1. So degree is 5. So degree is 5. That means odd degree. Perfect. Leading coefficient is when you multiply all these x's. Now this is always positive, square is always positive. This is positive. So the leading coefficient is positive. So leading coefficient is positive, degree is odd. Okay, that means what? Well, I'll show you on the graph. That means what? So that's also time for us to sketch. So let's say we'll just plot this. Okay, so what we have here is three zeros. Okay, let's first finish off with the end behavior. So end behavior, we said that we have odd degree with positive leading coefficient. Positive means right side up, whether the degree is odd or even. Positive means right side up. Okay, positive means right up. Remember that. And odd means opposite ends. Opposite ends. So if it is going up, right, it has to come down here. So that is what we're trying to say. Odd degree means opposite ends. Positive leading coefficient means right side up. Okay, so we've done that part. Let's begin by plotting x-intercepts, which are at 0, 2 and minus 1. So let's say this is our 0, and let's say this is 2, and then let's say this is minus 1 for us. Remember, we have to begin from quadrant 3. Now these zeros now this one, which is at -1, has multiplicity of 2. So it behaves like a parabola. At this point, you cannot cross the line. You have to turn, right? At 0, multiplicity is 1. So you're there in quadrant 3, so you have to cross like a straight line. At 2, multiplicity is 2, even. So you will jump, bounce back. So that is how the graph should be, right? Now connecting these points with a smooth curve represents a polynomial. So what we will do here is that we can just graph it like this, right? So that is going down, and this one, you see how we have connected, right? So this goes like this, bring it down, and then just go up, right? And behavior, do you see it moves from quadrant 3 to 1, going through the zeros which are at -1, 0, and +2. The multiplicity at -1 is 2, it bounces back. At 0 is 1, linear, goes across. At 2, again returns like a parabola, right? So that is how you should be graphing. So this is your x-axis, you can label this, and that's the function g of x. Y-intercept in this case is 0, so it goes through origin. Zeros decide the behavior of a function at x-intercepts. If it is linear, the graph will cross like a line. If it is quadratic or even, it will bounce back. I hope with this you learn a lot and there should not be any difficulty in sketching polynomials. All the best. Thank you.